Okay, we'll go to the Unit 7 practice test video. Okay, centered. Alright, here we go. So, question 1. The mean advertisement for a medicine claims that it can provide allergy relief in an average of 60 minutes. So we're going to underline that it's going to be our claim, right? Because it is a claim right here. That's kind of a key word. A random sample of 33 people, also important, with allergies, given medicine and asked to record how long it took them to feel relief. The mean time was 61.3. That's of those 33, okay? With a standard deviation of 4.6. Conduct a hypothesis test to see if the company's claim is accurate or not. Okay, so the parameter is what we're measuring in words, and that is the true mean time or response time to medicine. Okay, significance level is given to us as 0.05. Our null hypothesis. So the key thing here is, are we dealing with means or are we dealing with proportions? Well, it's very clear here. Look at this word mean, that it's a mean. So when you know it's mean, you're going to go to that right side of your sheet, this side right here, and basically following all of this. So these are the symbols that you use, and this is the process you're going to use. So mu is our population mean. That's what goes into our hypothesis test, our hypotheses. So your null is going to be that your mu is equal to the claim given 60. And in this case, because my mean time was 61.3, and that is greater than 60, it looks like maybe the mean time is greater than 60. So we're going to say that our mu is greater than 60. That is our alternative. Key thing here is that these numbers are always the same, 60, 60. These symbols are always the same, mu, mu. This symbol is always an equal sign. It's this one that's different. It's either greater than or less than. Okay. Our X bar is our sample mean. So refreshers, this is the sample mean. That is going to be our 61.3, which was given in the question. We have our standard deviation here. It's going to be our 4.6, again given in the question. And then our N is 33. That's our sample size. Okay, so make sure you know what those letters mean. Sample mean, standard deviation, sample size. And you can put them on the back of your notes, right? The back side of your notes, you can do that, okay? Plan, name of the procedure. So now that I know it's a mean, I'm just gonna follow my steps here for mean. So it's a one sample t-test for mu. Is a random condition met? Well, it says that they took a random sample. Yes, it was a random sample. Is a normality condition met? To meet the normality condition for means, there's a few different options, but a common one is that the sample size is bigger than 30. And so, yes, because 33 is greater than 30, it is normal. So we're good to go. Okay, now we do the do. We get the standard error. Again, just using our formula, our standard error is this Sx divided by square root of n. So Sx over root n is going to be here in the calculator. It will be 4.6 divided by the square root of 33. Sorry. 4.6 divided by the square root of 33. Enter 0.8. So 4.6 divided by the square root of 33 equals 0.8. T-statistic, again, same thing, using the formula, is the X bar minus the mu over what we just found. So my X bar, again, is at 61.3 minus the mu 60 over 0.8 equals So let's calculate. Make sure you do the top before you do the bottom. So we're going to do 61.3 minus 60, enter, divided by 0.8 is 1.625. Okay, degrees of freedom is n minus 1, so it's 33 minus 1, so it's 32. And then our p-value we're going to get from our t-table. So to do this, we know that our degrees of freedom are 32. So we go to our t-table and we go down to 30 because it's the closest one, and I'm looking for 1.645, and I see pretty close here, 1.697, and I go up, and so it's 0.05. It's the middle one right here. That's the one tail is the one that we care about for this test, 0.05. So the p-value is 0.05, and so because 0.05 is less than or equal to our alpha, which is 0.05. So again, if this is less than or equal to our alpha, we reject. And so we do have evidence that could be wrong. Okay? That is for the means. And on the back side, we have a question for proportions. According to ESPN, basketball player Steph Curry successfully made 90.9% of his free throws taken in his career. His teammate Klay Thompson thinks they aren't given enough credit. So he takes a random sample of 150 of Steph's free throws attempts. He finds that Steph made 140. Conduct a hypothesis test to determine whether ESPN got this wrong. So key here is, are we dealing with means or proportions? Well, see this percentage. This indicates to me that I'm dealing with a proportion, not a mean. Okay. So same thing. Let's go through it. So this is the claim, right? That it's 90%. That's what we're given to be true. Klay Thompson thinks they're not giving enough credit. We take a sample of 150, and he makes 140 of them. Okay. So this is going to be that n right here, and that's 140 out of 150. So our hat is 140 over 150. And our P will be that original claim, which is 0.909. Follow me? So that's coming from that. Our P hat is from our sample, the 140 out of 150, which is, let's do it, 140 out of 150, 0.93. And then that's our N, is the 150. Kind of have, once you have like your P hat, and your N, you're good to go on proportions. The parameter that we're looking for is like the true proportion of Steph Curry. The null is going to be that our P now, because we're dealing with P. Right, you can see that here. The two, like you can see which letters you're looking for from the chart. Our P needs to equal 0.909 because that's the claim originally. That's what ESPN says, so we're trying to prove that wrong. The alternative is that, well, based on our sample size, it's bigger. Right, so we say that P is greater than 0.93. The name of the procedure, again, I'm getting this all from the table. It is a one sample Z test for P. One sample Z test for P. And here below, this is there's kind of a typo here. This should not be in there. And this is the large counts. Normality is large counts. Okay. So the randomness condition, yes, because it's a random sample given the question. Normality condition meant, so this is the large counts. This is when you have to do NP greater than or equal to 10 and N1 minus P greater than or equal to 10. So we're going to do 150 times 0.909, and then we'll do 150 times 1 minus 0.909. Always use P for the equations, not P hat. P hat only comes in at the end. So that's 0.909 times 150. It's big, right? It's 136-ish. And then 150 times 1 minus 0.909 is 13. So we're good. 0.65. So we're good. All right. Standard deviation, getting this from the table, is right here. This is the standard error, so it's the square root of p, which is 0.909 times 1 minus 0.909 over n, which is 150. Okay, put it on the calculator. So again, we do 0.909 times parentheses 1 minus 0.909, close it, enter, divide by 150, enter, and then square root that, and we get 0.02, right, 0.023. 0.023 is my standard deviation. Z-score is the same kind of form as the previous one. It's the statistic minus the null divided by that standard error that we just found. So it's going to be my p hat, which is 0.93, minus 0.909 divided by 0.023. So it's in the calculator. 0.93 minus 0.909 divided by 0.023 is 0.913. 0.913. Now we need the p-value, so we go to our z-table, not the t-table, we're going to go to the z-table, and we're going to look for 0.913, 0.91, which is 0.1, right? So it's 0.91 is 0.8186. So thing is 0.8186. That the p-value always gives the value to the left, right? But I don't want the value to the left. I want the value bigger than this. Like p-value should be small. The p-value should be a small value. I know that I want it to the right because my significance test is to the right. So I want it's not a big number. It should be a smaller number. So it's 1 minus that, which is 1 minus 0.8186, 0.18. And because that is bigger, 0.18 is bigger than 0.05, we do not reject the null. We do not have evidence. If we got this wrong, that would be a type 2 error. Little review about the errors. I'll put this at the end here. Put it back on the back of your review sheet right here. Put this in the back. Make this table. So you have true, false, reject, fail to reject. If you reject and it's true, that's a type 1 error. If you reject and it's false, that's good. If you fail to reject and it's true, that's also good. But if you fail to reject and it's false, then that's a type 2 error. Okay, that's it. All right, good job, guys.